I've recently been adding subtitles to some of my YouTube videos, and to make life a bit easier, I've partly automated things using some Visual Basic programming with an Excel spreadsheet. I thought it might be useful to show how I've done this. Using Visual Basic can be very helpful when you've got repetitive operations to do on your data. You need to invest some time in setting up the program, but then it can save time in the long run if you need to do things over and over again. And also, it's a lot less boring than repeatedly doing things by hand. So let's have a look at what I did. First of all, I set up a spreadsheet with the subtitle data. Here are the headings. Each subtitle has a serial number starting at 1. Then there is the start time, taken from the beginning of the video, in hours, minutes, seconds and frames. The next 4 columns give the end time in a similar way. Finally, in column 10 is the subtitle text. All this data is on a single row of the spreadsheet for each subtitle. Let's load some subtitles into column 10. These came about by transcribing the soundtrack of the video and were put into Notepad as single lines of text. Now I'll set up row 1 with a 1 as the first subtitle number, then zeros in all the start and end time columns. I say row 1, but because of the headers this is actually row 3 of the spreadsheet. Subtitle numbers in column 1 increment by 1 for each row, so I'll put in a simple formula, A3 plus 1, which of course returns 2 in the second row of subtitles. Now in running speech, the end time of the previous subtitle can be made the start time of the next. So I put in some formulas to copy the previous end times into the start times of the next subtitle, and then copy everything down to the bottom of the subtitle data. You can see how the data entry works if I put in some end times. They are copied into the start times on the row below, which for most subtitles saves you having to enter the same time again as the start time of the next subtitle. Of course, if you don't want the subtitle to start immediately after the previous one, you can overwrite the formulas in the start columns with the required times. Now I'll magically make some real timing data appear. So there you can see the subtitle data all filled in on the subtitle data worksheet. I also have a blank worksheet labelled output, which is where we'll put the processed subtitles. Now let's have a look at the way we want the subtitle data to be formatted. I've chosen the .srt file format, which is relatively simple and is one recognized by YouTube. Here's a file in the SRT format. It's a simple text file, so viewable using Notepad or any text editor. Each subtitle occupies at least 4 lines of the text file as shown. The first field is the sequential subtitle number pointed to here, incrementing by 1 each time and starting at 1. Now let's have a closer look at one subtitle. That's the subtitle number 3 in this case. On the next line is the start time and end time. These are separated by a text arrow using 2 hyphens and a right chevron symbol. Note there must be a space before and after this arrow. On the next line is the subtitle text. It can actually extend over 2 or more lines. This can be useful if you want a long subtitle to be broken in a particular position when displayed. I usually rely on the YouTube processor to break long subtitles at an appropriate place, which it usually does, for example at a word boundary. Then, most important, after the subtitle text there must be a blank line. This is how the subtitle processor knows it has come to the end of the current subtitle. The start and end times are made up of hours, minutes, seconds and milliseconds, that's thousandths of a second. Each of these numbers has leading zeros, so for example 6 minutes is shown as 06. The millisecond field has 3 digits, so 6 milliseconds would appear as 006. Between the hours, minutes and seconds there is a colon separator, and between the seconds and milliseconds the separator is a comma. You may remember that the spreadsheet data has frames as the fractional part of the seconds instead of milliseconds. To get the required milliseconds figure, we multiply the frame number by 33.3, as each frame lasts 33.3 milliseconds when the video is running at 30 frames per second. So we want to get this .srt format from the data that we have on the subtitle data worksheet. You can see immediately that whereas in the spreadsheet all the data for each subtitle is on one line, In the subtitle.srt file, the data is spread out over at least 4 lines, so we have to take each of the subtitle data fields and split them up onto consecutive lines of the output text file to give the required format. So now let's have a look at the Visual Basic code I wrote to take the all-on-one-line subtitle data and put it into the .srt format where it extends over 4 lines. To get to the Visual Basic editor in Excel, you choose the Developer tab, then press Visual Basic. As this editor uses quite small text, and I could not find any way of increasing its size, I'll replicate the code in an editor which does allow bigger text so you can see it clearly. I always start any code I write with some comments showing the program title, author, and most importantly the version number and date. All of this is useful if you want to print out the code, and also the version and date information can be vital to ensure that you modify the latest version anytime you need to in the future. Note that in Visual Basic, comments or remarks are preceded by the apostrophe, or you can use the much older rem prefix, but the apostrophe is preferable as it makes things easier to read. After this, I usually put some comments with a description of what the program is intended to do. Again, this makes it easier to understand if you need to do modifications after a few months or even years. Next comes the compiler instruction, option explicit. This forces you to make prior declaration of variables before you reference them in your code. I heartily recommend that you follow this practice as it can prevent you making silly mistakes in typing variable names and wasting extra time in debugging your code. Next comes the global variables definition. In the present program we don't have any, but I always leave this line in to remind me to declare any. Just a word here about the convention that I use in naming variables. Any global variables have names starting with a capital letter. For example, error found is global, whereas local variables start with lowercase. For example, subtitle number is a local variable. Just to clarify, a local variable is only accessible inside the procedure or subroutine it is declared in, whereas a global variable can be read and written to anywhere in your code, either inside or outside a procedure. The other thing to say about variable names is that I deprecate using the underscore character. Instead, capitalize words as shown here, which makes things much quicker to key in. And when it comes to strings, I add the suffix str to the name to remind me that it is a string of characters and not another type of value. Now we start writing our code. I'll set up a subroutine or procedure by typing sub, then the subroutine name, which I will call scan and output. You put an empty double bracket at the end of the name, as this is where any arguments passed to the procedure would go. In this case we don't have any. When you press return, the editor automatically puts in an end sub line to define the end of the subroutine. After the end sub statement, I always put a comment to show which subroutine this is the end of, to aid in future work on the code. Next, I add at least one line of comments to describe what the subroutine does. This again can aid in future modification or bug fixing. After this comes the variable definitions using the dim or dimension keyword. First comes dim substring as string. This means that the variable substring is declared as a string value, that is a series of characters. Note that also my naming convention has been used. Substring is a local variable because it begins with a lowercase letter, and substring is used to hold the text of the subtitle being worked on. Next comes subnum as long. This is the subtitle number. Next, I declare variables to hold the start time, hours, minutes, seconds, and frames. These are declared as integers, as they should never be above 59 in value. At the end of the line, I declare the variable start string. This will hold the string value of the start time. A similar set of variables is declared for the end time of the subtitle, for example, end mins. The final set of declarations is for in-row and out-row. In-row specifies the present row being read from the subtitle datasheet, and out-row gives the row we're writing to on the output sheet. So you can see that the top 3 rows of variable declarations refer to the subtitle data, whereas the 4th row gives information on where the data comes from and goes to. Now I'll specify some initial conditions. First, we'll clear the output sheet using this command, which is quite self-explanatory. Next, I set substring, the subtitle text, to a non-blank value. In this case, it's just dummy. This is so that our loop, which I'll come to shortly, has something to start off with. Then we specify the starting row for input data, variable in-row, which is 3 because there are 2 rows of headers on the subtitle datasheet. Out-row is set to 1 to point to the first row of the now empty output sheet. Now I'll just scroll up a bit to give us more room. Now I'm going to scan through the subtitle data in consecutive rows of the subtitle data sheet using a do loop. The construct is do until substring equals blank. In other words, go around the loop until a blank line is found in the subtitle data sheet, that is the first blank row after the starting row of 3. Next I put a with statement. This works as follows. These two statements set substring to be the value on worksheet subtitle data in the cell specified as in row 10. The cell is identified by row and column as shown. Variable subnum is similarly set to the value in cell in row, 1. However, to avoid having to type worksheet's subtitle data over and over, we can use the with and end with statements. As you can see, any cells are automatically qualified with worksheet's subtitle data when included between the with and end with statements. And just before moving on, note how I've indented the statements between the with and end with. This makes it easy to see what the with statement refers to. I continue with loading the subtitle data variables from the subtitle data sheet. There are the start times, hours, minutes, seconds and frame. And there are the end times similarly. Now we have all the data for one subtitle in our local variables for this subroutine, and I'll just put in a comment to that effect above the with statement. Now I'll begin to output that input data. That's a with end with construct to point to the output sheet. Firstly, let's put the subtitle number, subnum, into the first row of the output sheet. Note that it is turned into a string using the Visual Basic function format. The more usual function to do this in BASIC would be the string str function. However, return value for this function has a space as the first character for positive numbers. For negative numbers, this is where the minus sign goes. Format does not add the leading space, so is preferred here. After subnum is written, the outrow variable is incremented, 1 is added to it, so that the next output will be on the next row of the output sheet. Next, the start and end times must be output. For the time being, I'll substitute the time strings with the words start and end in the start string and end string variables. These are then written to the output sheet with the arrow separator. Once again, the outrow variable is incremented to point to the next row on the output sheet. The last thing to be passed to the output sheet is substring, the subtitle text string. Again, the outrow variable is incremented to select the next output row. Finally, in the loop, the input row variable in row is incremented, so that the next time around the loop, the next line of subtitle data sheet is selected. Let's take out the blank line so we can see the whole of the do loop at the one time. There's the do loop statements, with the loop continuing until substring is blank. Those statements read in the subtitle data into the local variables, and these statements output them to the output sheet. Finally, this is where the in-row variable is incremented to step onto the next line of input data on the subtitle data sheet. Note that if this was missing, the program would go into an infinite loop, as the data would be read out from the top line of subtitles continuously and would never reach a blank line. Now let's run this subroutine. Save the basic visual code. That's most important in case you have a problem such as an infinite loop, which trashes the computer. Then back in Excel proper, select the developer tag and then macros. Here you will see our subroutine listed. Select Scan and Output and press the Run button. Now we'll look at the output sheet. You can see that the subtitle data has been written out on successive lines as required by the .srt format, but with the words start and end instead of the actual times on the second line of each subtitle's data. You may notice that there is a problem. There is no blank line after each subtitle's text row. Go back to our Visual Basic code. The problem is in the highlighted line of code. After the subtitle text substring has been written, outro is incremented by 1. We need to change this to 2 to leave a blank line between each subtitle's data, like so. And note the comment is updated to remind ourselves why the increment is 2 rather than 1. Let's run the code again and see what we get. Now the subtitle data is separated by a blank line as required by the .srt format spec. But if we scroll down to the bottom of the subtitle list, you can see there is an orphan subtitle at the end with no text in it. Why is this happening? Well, remember that the do loop executes until substring is blank. So when substring is read as blank, the loop continues with the output of rubbish data. This can be easily fixed by making all of the output statements conditional on there being a non-blank substring. See the if, then, end if. Notice how I've indented everything in between the if and end if to make it clear what part of the routine is affected by the if, then condition. Let's run the subroutine again and check what it does. There, the orphan end row has gone. Now I've got to do something about getting the start and end times into the right format of hours, minutes, seconds and milliseconds with leading zeros, comma separated before the milliseconds and colons between the other fields. To do this, I'm going to write a function which I'll call makeTimeString. After putting the double bracket and pressing return, the editor automatically puts in the end function statement. As before, I comment this to show which function it is the end of, to aid future modifications, etc. In the brackets, I'll list the parameters that will be passed to the function. They are hours, minutes, seconds and frame, each one declared to be an integer value. The function will return a string value, hence the final asString on the line. As with the subroutine above, I then add several lines of comments saying what I want this function to do to aid in future work on the code. I next declare the local variables, two strings, outString and workString, and a double variable, millisec, which will be used in calculating the millisecond value from the frame number. Next, outString is set to empty. The function output result will be built up in this string as we go along. Firstly, I use the format function to create a string from the integer value given in the hours parameter. So a value, for example, of 2 hours would result in the string 2, 1 character long. This is then concatenated with a double zero string 00, giving the result 002, 3 characters long. We then use the write_to function of Visual Basic, which returns the right-hand 2 characters, so we get the string 02. Thus the leading 0 requirement is satisfied. Next, this result is concatenated with outString, which is presently blank of course, together with the required colon separator. In exactly the same way, the minutes and seconds are added, so we get the hours, minutes and seconds in the format required. For example, 02:34:07, comma, for 2 hours, 34 minutes and 7 seconds. Now we do the millisecond calculation. We multiply the frame parameter passed to the function by 33.3, as that is the length of the frame at 30 frames per second, to give the millisec value. This will likely have digits after the decimal point, because it's a double type of variable. So I use the int function to strip away those and make it an integer value. Like before, I use the format function to turn this into a string and concatenate it with 30 string to ensure that the output string is 3 characters long with leading zeros. This is then concatenated with the previous strings onto the end of outString. This is the required output from the function, so finally the value of makeTimeString is set to outString. Now all that is required is to call this function from our scan and output subroutine. Here you can see that the start string and end string are assigned to the value from the makeTimeString function. Now let's run the subroutine again and see if we get a good output. You can see that the subtitles now have the full start and end times shown. It's now possible to copy and paste the data on the output sheet into a text editor like Notepad and then save it as a .srt subtitle file. Finally, a note: garbage in equals garbage out. There's absolutely no error checking. You can enter anything you like on the spreadsheet. Some values will generate an error and stop the Visual Basic program running. Others will just produce an incorrect output. So all values should comply with these requirements. A possible extension of this code would be to add error detection and protection, but that's a bit further than I want to go with this right now. So there you can see how a fairly simple bit of Visual Basic code can automate a data manipulation job which would be quite tedious to do by hand. It took me a bit over 1 hour to write the code and debug it. I followed pretty much the steps I showed here. Firstly, getting the subroutine scan and output working, and then adding the function makeTimeString to get the times formatted correctly. It's not a very sophisticated bit of software, there's no error checking at all, but for subtitles it's not important. The YouTube subtitle processor will pick up some errors, or they'll become obvious when you view the video. You can automate just about anything you can do by hand in Microsoft Office using Visual Basic. The only problem I find is that searching through the Microsoft documentation is pretty impenetrable at times. Anyway, I hope this has inspired some of you to give Visual Basic a go and wish you the best of luck with it.